with that, I will pass the floor to Mary for her presentation. And Mary, the floor is yours.
All right, thanks a lot, Gerald. Can you hear me okay?
Yes, just fine. All
right, great. I am going to be talking about something a little bit different today than most of the installments of It's Money. I'm going to be talking about saving money with enhanced subsurface characterization. Typically, the It's Money installments have been talking more about testing foundations, but it's also important to be testing the soil that you're building on. I think it's more of a challenge to demonstrate that soil testing actually saves money, but it's just as critical of a component. And I'm going to be getting into some of the data and case histories that show that you really are saving money by doing this. So this is a brief outline. I'm going to introduce the Subsurface Characterization for Deep Foundations Committee of DFI. I am the chair of this committee, so I'm representing some of our interests and goals here. I'm going to talk about what we mean by enhanced subsurface characterization, and I'm going to talk about some of the challenges that we have in demonstrating the value of subsurface characterization as opposed to some other testing methods. And then I'm going to get into some of the data showing that subsurface characterization can indeed save money, and I'm going to be looking at some different ways, including direct cost savings, reducing design uncertainty, and reducing construction risk. So like I mentioned, I am the chair of the DFI Subsurface Characterization for Deep Foundations Committee. While I'm here, I meant to do this at the beginning, but I also want to thank my committee members for helping me out with this presentation, in particular, Joe Smith and Andy Bachman, who is my vice chair. So these are some key aspects of our mission statement. We aim to educate stakeholders on the benefits of effectively managing ground risks. Whoops, sorry. We aim to promote the value improved subsurface characterization brings through efficient design, informed constructability, and more economical bids. And we aim to promote innovative technology where appropriate. In general, our focus is on the end users of subsurface characterization data, which is a little bit unique relative to some of the other similar committees in other organizations. So before I dive in, I want to talk about what I mean by enhanced subsurface characterization, because this is kind of a vague term. So enhance is to improve the value, quality, or extent of something. And I don't necessarily just mean doing more boreholes or more explorations, or even necessarily doing a program that costs more money, although it often can cost more money, even though in the long term it's worth doing. So here we see a comparison of the attributes of a basic subsurface investigation versus in what we consider an enhanced program. So basic program is what we usually see. They're not always inadequate. They're usually sufficient to characterize the soil that you need to characterize. You'll typically see standard penetration tests and typical lab tests to classify the soil, but they're not generally targeted at the specific needs of the project, or they're often not. They're also typically compliant with minimum code requirements. So you might see a minimum number of borings, for example, minimum boring depth, minimum amount of rock core, but engineering judgment may not be considered, and it may not be targeted at the specific project that you're doing. To contrast with that and enhanced subsurface characterization, there are lots of avenues to what we see as enhanced, and it really depends very much on the project. But some aspects that we pull together where you might see that it's specific to the ground conditions that you're actually dealing with. So you might get the information that you need for a complex design, for example, to do finite element models or some sort of analysis, and you kind of think about that analysis and what information will you need to perform that analysis. An enhanced program might be designed, so rather than just doing a compliant program, you'll actually put some initial upfront effort into designing the program specific to your project and to gather information in the areas that matter. It might use advanced techniques, and I want to qualify that a lot of times when I say advanced techniques, these are not necessarily really new techniques. Many of them have been present for decades, such as CPTs and geophysics and more complex lab tests, but the industry has been pretty slow to adopt a lot of these methods, so they're very underutilized. And finally, an enhanced program might be phased, and this can definitely be more of an investment, but if you do multiple phases of an exploration program, you can refine the program in subsequent phases to kind of target the information that you need and learn more at each phase about the subsurface conditions. I'm going to go through some examples of what enhanced subsurface characterization can look like, and this is definitely a non-exhaustive list, but just to give people a little bit more of a picture of what it could be. So like I said before, some more advanced methods that you might see are the use of CPTs or DMTs, dilatometers. These can give you continuous data on shear strength and stress state of soil, the stiffness, the consistency of the soil, rather than just getting individual SPT samples. You can gather a lot of data really efficiently. You might do pre-fieldwork preliminary design. This would be designing, maybe doing some upfront design so you can really target the program at the unknowns that you are trying to address. You could do surface wave geophysical testing. This would help you provide data in between discrete points, like CPTs or SPTs, so that you could really develop the stratigraphy over a wide area without doing more borings or CPTs. You might do large-scale pump tests to provide improved quality mass permeability data. You might do thin-walled samplers if you really need very high-quality lab tests and reduce sample disturbance. You might do advanced triaxial testing to inform the strength and stiffness parameters and get the information you need to do a complex finite element analysis. So again, these are just examples that would vary project by project, but there are many avenues that you can take to be doing an improved subsurface characterization program. So before I move on, I want to springboard off the discussion of what an enhanced subsurface characterization program is and briefly introduce the FHWA Everyday Counts program, which we call the A game. So Everyday Counts is an FHWA program that provides funding and support to deploy underutilized effective technologies. And right now, one of the highlighted technologies is the Advanced Geotechnical Methods in Exploration, or the A game. So it was started in 2019, started talking about it in 2018 to plan. So right now, this program is being deployed. So there is funding and support by the FHWA for states to use more advanced methods in geotechnical exploration and show how that can provide value to projects. So the highlighted methods are listed here on the right: cone penetration tests, geophysics, measurement well drilling, which is gathering information on a continuous profile on your soil to differentiate between strata and get additional information that you can correlate with shear strength properties while you're doing exploration drilling, so you can get a continuous profile from a drill rig. And finally, optical and acoustic televiewer, which is a way to gather images of rock cores. So again, these methods are not new, they're just underutilized. They've been proven to work, and we're trying to get states to adopt them more effectively. So this is really a pretty exciting time to be looking at geotechnical explorations and talking about them and trying to promote them, since the FHWA has this platform to improve geotechnical investigations on transportation projects. And if you want to know more about that, the internet, if you look on the internet, search A game FHWA, it pops right up. Okay, so it might seem challenging, it might seem obvious to geotechnical engineers how that subsurface investigations are valuable, but it's actually very difficult to quantify this, and there are a few reasons for that. Generally, cost savings related to subsurface investigations are not direct cost savings. They can be direct cost savings, as I'll talk about in a few slides, but they're often not. They can be related to design efficiency. So you do a better investigation, you get a more efficient design, but we only construct a building or a bridge once, so we don't get to see the different impacts of various choices that we make on the efficiency or inefficiency of a design. And success stories are often not publicized. If you have a project that goes well and is designed efficiently and has a good geotech program, you don't necessarily get to kind of review that and quantify it and learn from it. Just everybody just moves forward. And the second indirect way that you can get cost savings is by reducing project risk. So change orders, cost overruns, and claims, you can reduce those and ultimately save money. This requires voluntary disclosure of costs, which we're working on gathering this information, but it's very challenging. Failure data are often proprietary. People don't want to talk about it. And change orders related to geotechnical issues are not well documented. So I am going to dig into 3 ways that you can save money with concrete examples for each one. The first one is direct cost savings, and the second 2 are more indirect, reducing design uncertainty and reducing construction risk. For direct cost savings, I have a case history. This is a very simple one, but it kind of shows you that even on small projects, there's potential to save money by just doing a little more creative thinking on your exploration program. So this was a bridge replacement project on Cape Cod in Massachusetts. It was built in the original bridge was built in 1935 and it needs to be replaced. The construction has not happened, but the geotechnical exploration is complete. So this is an image showing the boring or the exploration location plan for the new bridge. So you can see the proposed piers in blue. There's a lot fewer of them than on the 1935 bridge. The program included just 3 borings and 8 CPTs rather than doing a boring at every bent. The borings were drilled at the 2 abutments, and then from the 2 at the abutments and 1 in the main span pier in the middle, and then the CPTs were done at all the other bents, with 1 CPT done immediately adjacent to a boring to calibrate the CPT data. And all these were done from the existing bridge deck. So the use of CPTs in this particular program saved $25,000 in exploration costs, which was about 25% of the subcontractor fee. So that for a small project like this, that was a significant savings. It reduced the need for laboratory tests and expedited the exploration program, both of which save more money. That I don't have that quantified yet, but you can probably understand that would save additional cost. And it'll also allow for the use of direct pile design methods using CPT data. This project, we provided capacities for tapered steel piles using the CPT data directly, which was much more efficient and preferable and more accurate, likely, than using the SPT and values. So just the takeaway from this, you can save money directly in exploration programs by making the right choices on the types of explorations that you do. So SPTs provide valuable data, but this routine approach is not always optimal for all projects. CPTs gather continuous data quickly and can reduce the number of SPTs needed. I will note that you need to have the right kind of soil for CPTs. Obviously, if you have shallow bedrock, you're not going to be able to advance CPTs. And if you have very dense fill at the ground surface, you might need to pre-drill, or CPTs may not be optimal. But for this project, this is in an area, in a state that does not frequently use CPTs. But Mass DOT realized that it would have potential cost savings and brought in a CPT rig from out of state. Geophysics were not used on this project, but that's another way that you can gather large quantities of data quickly and allow for more strategic placement of SPTs or CPTs. And this is kind of an example, like I mentioned previously, of a phased approach where you might do geophysics first and then plan the rest of your exploration based on that. So the second way that you can save money is by reducing design uncertainty. And this is kind of an indirect way, but it's a concrete example where Missouri DOT specifications allow for an increased resistance factor with more data. So this chart is showing, this is for drilled shafts in shale, and this comes out of the Missouri DOT standard specs. You can see that as the coefficient of variation of the unconfined compressive strength test goes down, the resistance factor that you're allowed to use goes up. So basically, if you have a higher resistance factor, you're allowed to apply more load and you get more cost savings. So this is a direct, this specification allows for direct cost savings and more efficient design by if you have more data. So Missouri estimates that the cost savings from reducing design uncertainty, I'm actually not sure if this is, oh, sorry. To date, I don't know the time span over this, but they estimate about $40,000 per bridge, which is substantial once you add it up. I believe that this is in progress in Oklahoma, and hopefully more states will adopt similar methods. So the third way that you can save money from subsurface characterizations is by reducing construction risk. This is another indirect one, another very challenging one to quantify, but the idea is if you have more or better data, then the contractor can include less contingency in their bid, and that can save money. If you have more and better data, you have fewer surprises, which leads to fewer change orders and claims. And if the contractor can design for the right conditions, they can use the right means and methods and ultimately be more efficient and stay on schedule, which can also save money for the owner. So this image is showing the cover of an NCHRP synthesis. Andy Bachman and Eric Lohr from the University of Missouri were contributors to this, and it was published by TRB. It's great data and discussion on this topic. The name of the synthesis is The Influence of Geotechnical Investigation in Subsurface Conditions on Claims, Change Orders, and Overruns. And they did their best to gather data on this specific issue. And so I'm going to present a little bit of that in the next few slides. So this first chart shows an annual magnitude of change order cost due to subsurface conditions for 5 states. This is from the synthesis. I want to note that this data was very difficult to collect, and all the states and agencies were actually surveyed, but only these 5 were able to present the data. All of them did note, or most of them did note, that cost overruns and claims were a priority concern for the agency, but that's just qualitatively. So you can see here that there's a lot of money that is getting lost from this, many millions of dollars. And even if this impact is not huge to the agency as a whole on any individual project, it can have a huge impact. Several $1 million can be a huge impact on a single construction project. You could pay for a lot of subsurface investigation for this money, and a lot of this could have been avoided if you'd known more about subsurface conditions. This next chart is really interesting, and we're working on gathering more data in this realm. But what this chart is showing is that basically it's the cost of site investigations on the x-axis as a % of project cost awarded. So as you move to the right, you're spending more on your geotechnical investigation. The y-axis is showing the increase in construction costs greater than the project award cost. So that's like claims and cost overruns as a percentage of the project cost. So you can see that as you spend more money on site investigations, you tend to end up with fewer cost overruns. I want to point out a few things about this chart. These are all bad outcomes, and each of them are cost overruns. So you're not seeing good outcomes at all in terms of if you had a great site investigation and no issues, it's not on this chart. There's a lot of variability on the y-axis. There could be a lot of reasons for that, but I think some of the takeaways from that might be that some explorations are better than others. You don't necessarily have to spend more money to get a good investigation. You know, down here in the bottom where you're not getting a lot of cost overruns, you still have a lot of less expensive investigations. Could be that you got lucky, could be that you designed the exploration with more thoughtfulness and you sort of had a smarter exploration, not necessarily a more expensive one. The blue points are from the NCHRP synthesis. The red points I added, and I'm going to talk a little bit more about this in the next slide, but these are from the Army Corps, which is currently actively collecting data for this, similar to this in terms of what was the geotechnical investigation cost, what was the construction claim cost. And you can see that the red data points fit pretty well with the rest of the data. So like I just mentioned, the Army Corps of Engineers is currently collecting data on claims related to inadequate subsurface characterizations. They've shared 6 case histories with our committee to date. The ones that I had geotechnical costs for, I included on that chart on the previous slide. They found that all of these could have been avoided with more geotechnical information. And some examples of the reasons are unknown subsurface debris, inadequate estimate of rock excavation quantity, the top of rock not being accurately characterized, and unknown subsurface contamination. So in conclusion, I have provided examples and data showing that enhanced subsurface characterization can save money. There are many avenues to this. They can save money directly, or they can save money indirectly through reduced construction risk or reduced design uncertainty. And it can be really difficult to quantify the cost savings. And that's a lot of what our committee is working to do and working to communicate to owners and to contractors so that more investment can be made in geotechnical investigations. I've tried to show you that site characterization and risk are directly related. If you have a poor site characterization, you end up with very cautious and conservative engineering design and a contractor bid that has a lot of contingency. With an average site characterization, you're somewhere in the middle, and with an excellent site characterization, you can have more efficient engineering design and a confident contractor bid and save much more money than you spent on the investigation potentially. And finally, to carry it forward, as you have seen and will see in other It's Money presentations, geotechnical risk management does not end when the project begins. You can gather data throughout construction by foundation testing and other methods to calibrate and verify your design. So it's not something that you should consider one and done at the beginning of a project. It should be kind of continued and thought out as the project is continuing to make changes and continue to calibrate. So that's all I have. Thank you very much for listening. Thanks for attending, and everybody stay healthy and safe.
Thanks, Mary, for a very interesting presentation. And hopefully some of the case studies that you mentioned that have been shared by the Army Corps can be topics of presentations in the same series at a later date.